Okay, you guys, this is Mr. Convery here. Today we're going to take a look at Chapter 8, Lesson 1. It's volume of cylinders. If you are from Mrs. Durbin's class, welcome. If you are from Mrs. Bagot's class, welcome. If you are from Sowers, from Mr. Johnson's class, or Mr. Riley's class, welcome. They've done a whole lot of work on this. I am doing the video lesson. Okay, so we are going to take a look at problem number 1 here. So problem number 1, the volume of a cylinder, and we'll go ahead and write that down, you guys. The volume is equal to pi times the radius squared times the height. Now, if you are new to the videos here, I want you guys to understand that it's kind of difficult to write with the digital pen, so it gets a little bit sloppy at times, but I'm sure you guys can just kind of go with the flow and we'll figure that out. Okay, so the volume is equal to pi, and let's go ahead and just use 3.14. If you have a calculator with the pi key, you can use the pi key. If you don't, just use 3.14. Let's go ahead and do times the radius. Now the radius is just halfway across the circle, so halfway across this, the top is just going to be 5, and we're going to have to square that because it's radius squared. So let's make that into a 2, and then we're going to go ahead and multiply that by the height, and then the height is simply 8.3. Okay, order of operations tells us that we have to take care of the exponents first. So we're going to say volume is equal to 3.14 times 5 squared, and that's going to give me a 25, times 8.3. Now, the commutative property of multiplication allows me to multiply in any order, so I could do 3.14 times 25 times 8.3. I could do 25 times 8.3 times 3.14. It just doesn't matter. So let's go ahead and multiply straight across here. And when I multiply straight across, I get 651.55. The instructions are asking me to round to the nearest tenths. So let's go ahead and make that 651. Instead of 0.55, let's make that a 6. We are dealing with centimeters, so I'm going to go ahead and say centimeters. When you're dealing with the volume, make sure that you cube your answer. Okay, there's one thing I want you guys to be aware of here. 3.14 times 25 times 8.13 will give us 651.6 after we round it. Now pi, if you're using the pi key, pi is 3.1415926, and it just continues on. So it's a little bit larger than 3.14. So if you are using the pi key, and you may have to use the pi key if you're putting your answers into Alex, then your answer would be a little bit greater than 651.6. So try it both ways. 3.14 times 25 times 8.3, and then try the pi key times 25 times 8.3 and see what you get. Okay, let's go ahead and move down to problem number 2. All right, number 2, we're going to do the exact same way. We are going to say, let me hit the pen tool here, you guys, and let me see if I can get the colors to pop up. Let's change that to, it's a yellow, let's change it to a red if it allows us to. There we go. So volume is equal to pi times the radius squared times the height. We're just going to fill in the blanks because it's easy. 3.14 times the radius. Now the radius is halfway across the circle, the diameter is all the way across. So all the way across is 16. That means the radius is going to be 8 because that would be halfway across the circle. Okay, they're talking about the top there. Times 8 squared times the height, and the height is going to be 20. So we are going to do volume is equal to 3.14 times 8 squared. 8 squared is going to give me a 64 times 20. We're just going to go ahead and multiply straight across. Commutative property there says that order does not matter with multiplication. And when we do, we're going to get 4,019.2 Let's look at the units, and the units are inches, so I'm going to go ahead and say inches. And when we deal with volume, we are going to bring that to the third power. All right. It looks like we have enough room here, you guys. Why don't we go ahead and take care of number 3, and I'll just change the color for that. So hopefully you guys know what the formula is for volume of a cylinder, and that is going to be, let's see if you got it, volume is equal to pi times the radius squared times the height. And let's see, we've got a metal paperweight is in the shape of a cylinder. The paperweight has a height of 1.5, nice and easy there, and a diameter of 2 inches. How much does the paperweight weigh if 1 cubic inch weighs 1.8 ounces? So this is easy, you guys. What we're going to do is we're just going to figure it out. We're going to get ourselves an answer, and then we're going to go, all right, if I had, if I happen to have 4,019.2 cubic inches, I would just multiply that by 1.8, and then I'm going to get my answer. Okay? So a little extra work, but not much. So we will say volume is equal to 3.14 times the radius. And now the diameter is 2. So if the diameter is 2, then the radius is 1. So we're going to say times 1 squared times the height. And the height is 1.5. So we'll do times 1.5. It looks like my digital pen is cooperating with me at this point here. So we're going to do 1 squared first. That just means 1.1. So we're going to do 3.14. 1 squared gives me a 1 times 1.5. And now what we're going to do is we're going to multiply that straight across. So we're going to say 3.14 times 1 is just 1. Actually, I lied. 3.14 times 1 is not 1. It's 3.14. And we're going to do 3.14 times 1.5, and that's going to give me 4.71. So 4.71, that's cubic inches, right? So we can say cubic inches. Actually, you know what, you guys? Why don't we just, let me see if, oh, well, we're going to go 4.71, and we've got cubic inches, and now they're telling us that 1 cubic inch weighs 1.8 ounces, so we're just going to do 4.71 times 1.8, and that's going to give us the weight of 8.478, and that's ounces, and they want us to round that to the nearest tenths. So let's look at this 47 here. So instead of saying 8.478, we're going to round it to 8.5, and then the weight of that is ounces, so we can just do 8.5 OZ. All right, part of that disappeared on us, you guys, but that's what's going to happen with this digital pen. So anyways, I think we have one more problem here, you guys. Let me scroll down the screen. If we do, we'll take care of that. If not, we are done. So we do have one more problem, you guys. In fact, it's called volume of a composite solid. That's really just when you have, maybe you have two shapes that are kind of added together. Maybe you had a square and a triangle and they were sitting on top of each other. That's a composite solid. In this situation here, we have like a cube, and it looks like there's a little cylinder that's kind of cut out of it. Let's take a look at this. It says Tanya uses cube-shaped beads to make jewelry. Each bead has a circular hole through the middle. Find the volume of the bead. So we've just got this cube over here, and then there's a hole down the middle of this cube. So we're going to find the volume of the whole thing, and then we're just going to take away the volume of that cylinder right there. So really what we have to do is we have to find the volume of that rectangular prism. And you probably remember that the volume is just going to be the base times the height. So I'm just going to say that the volume is going to be 12 times 12. Actually, base... yeah, that pause there, you guys. The pause was because of this. We don't want to do that. I'm thinking of a two-dimensional figure instead of a three-dimensional figure. So it's length times the width times the height. So what we have here is we have 12 across the bottom, 12 across the side here, and another 12 going up here. So the volume there is just going to be 12 to the third power. And I think you probably covered this in 6th or 7th grade. So the volume of that cube then is just going to be 1728. So the volume, length times the width times the height, so that's going to go ahead and give me 1728. Whoops. 1728. I don't see any eraser pens, so we're going to make this nice and messy. 1728. And that's going to be millimeters cubed, but I'm not going to worry about that right now. Okay, so that's the whole thing. So I have the whole thing, and now what I need to do is take away the cylinder that's on the inside. And they're telling me that that cylinder, all the way across the cylinder is 2, so halfway across the cylinder is going to be 1. And when we do the volume of a cylinder, we're going to say the volume is equal to pi times the radius squared times the height. So we'll say the volume is going to be 3.14. Now times the radius squared, well, halfway across the circle is 1, so we're going to do times 1 squared. And on the next line, that's just going to give me a 1. And then times the height, well, we know that's going to be a 12. Okay, because the height of the side is 12, so the height of the cutout is also going to be 12. So we can just say then that the volume is 3.14 times 1 times 12. And that's going to be the same as 3.14 times 12. So that's going to give me 37.68. Okay, that's the part that's missing. So what I'm going to do here is I'm going to go ahead and take the whole thing, and let me see if I could change colors here, you guys. So, well, I almost got a blue. Nope, it's still not doing that. So I'm going to take the entire thing here, which is 1728, and then what I'm going to do is I'm going to subtract 3768. And that is going to give us 1690.32. And do they want me to round it? They don't want me to round it here. They just want me to find the volume of each bead. So these are millimeters. So we're going to say millimeters. Millimeters. How's that? Cubed. That looks like AM, doesn't it, you guys? In any case, that is chapter 8-1. And I guess I'm going to call that our first COVID-19 lesson for the year. Okay? Hopefully you guys got that. Good luck on your homework. Check in through one of the conferences or through email if you have any problems. I don't think you will. You got a lot of resources out there. Worst case scenario, you guys could always just go to YouTube and do volume of a composite solid, and you'll see a bunch of people showing you how to do that. At that point,